Good morning, everyone. My name is Kolakoti Sriram Pawan Prasad. I am studying NITAP ECE branch third year. Today, I want to discuss about one of the optimization technique, which is known as Fibonacci method. Here, first I will introduce about the Fibonacci method. Then I will tell about the necessary conditions for Fibonacci method. Then algorithm of it. Then I will explain the code in Java. Then I will tell about Fibonacci method in n-dimensional space. And after that, I will tell the algorithm for how to solve the n-dimensional space. Fibonacci method is a type of optimization algorithm that is used to efficiently locate the minimum or maximum value of a unimodal function. A unimodal function is a function that has single maximum or minimum value within a specific range. In order to apply this, the following criteria must be satisfied. The initial interval we should definitely given in the question. If you don't have that, we will not able to do it. The function being optimized has to be unimodal in the initial interval of uncertainty. The exact optimum cannot be located in this method. Only an interval known as the final interval of uncertainty will be known. The final interval of uncertainty can be made as small as desired by making more computations. The number of function evaluations to be used in the search or the resolution required has to be specified beforehand. Now I will discuss about the algorithm and how to solve the Fibonacci method. Initialize the number of Fibonacci numbers to use n. The left endpoint is taken as A and right endpoint of the interval is taken as B. Here we will find the n value by using the formula 2 epsilon plus 1 by f of n plus 1 is less than or equal to final range by initial range. Here epsilon value should be less than or equal to 0.01. Now, after that, we will calculate the first n Fibonacci numbers and store them in a Fibonacci array. Set the length as b minus a and compute the length l equal to f of n minus k minus 2 by f of n into length. After that, calculate the values of x1 and x2 as a plus l and b minus l respectively. Evaluate f of x1 and f of x2 and store the values in f of x1 comma f of x2 respectively. Now we'll compare the values f of x1 and f of x2. If f of x1 is greater than f of x2, then we'll make the interval as x1 comma b. Or if f of x2 is greater than x1, then we'll make the interval as a comma x2. If in we have written the algorithm for the minimizing type. Now if you want the algorithm for maximizing type, we have to quite traverse the steps 6 comma 7. At each iteration we have to make sure that k value is increased. Repeat the process until k value is less than or equal to n. Now I will explain you the code of Fibonacci search method. First, initially we have to initialize the function. What is the function we want? What is the function we should have to define? And the initial interval of it we have to give. Then after that we have to find the n Fibonacci numbers. By using this block we will get the n Fibonacci numbers what we want. After that we have to define the length, which is equal to b minus a, and we have to find the length. For every iteration length will be changed. We want to find that. We'll get that by using f of n minus k minus 2 by f of n into l. Here a point will be equal to a plus L1, b value point 2 will be equal to b minus L1. We will find the both the values of the function at values point 1 and point 2, and we will compare the values. If value 1 is greater than or equal to value 2, a will be the point, else b will be the point. Now we'll get the final range of after computing the steps until k is less than or equal to, and we'll get the final range here. For maximizing type, we will do the same as above, but we'll change small difference. If value 1 is greater than value 2, then b will be the point. If vice versa, if then a will be the point. See here I've got the output. The initial range is minus 15 comma 15, but the final range is minus 2.6 comma minus 2.4, which the range is compressed. Here the range is 30, difference of the b minus a. Here b minus a value is zero point 0.2 approximately. Now I will discuss about the Fibonacci method in n-dimensional space. Fibonacci search method can be extended to n-dimensional space using a similar approach to the one-dimensional case. Instead of searching for the minimum of a function along one-dimensional interval, we will search for a minimum of a function over a n-dimensional hyperrectangle. The basic idea is to divide the hyperrectangle into smaller hyperrectangles using Fibonacci numbers. Similarly to the way we divide the interval into smaller subintervals in the one-dimensional case. At each step of the algorithm, we evaluate the function at the vertices of the hyperrectangle and discard the vertices that corresponding to the higher function values. We then repeat the procedure with the remaining vertices until we reach the desired level of accuracy. Now I will explain about the algorithm of Fibonacci method in n-dimensional space. Choose the starting point x naught in the hyperrectangle. Choose the level of accuracy epsilon. Calculate the number of Fibonacci numbers needed to get a division of the hyperrectangle into sub-hyperrectangles with a maximum stride length less than epsilon. Now after that, evaluate the function at the vertices of the hyperrectangle and sort them in increasing order of the function value. Discard the vertices that correspond to the higher function values. If the number of vertices remaining is 1 or 2, return the best vertex found so far. Divide the hyperrectangle into sub-hyperrectangles using Fibonacci numbers. Repeat step 4 to 7 until we got the desired level of accuracy.